Hi and welcome back to our next series of videos for Module 6. This is the second module in our Year 12 course and this module is called Acid and Base Reactions. Now to start off this unit, it is really covering some of the content that we've covered in our junior years, such as our naming of acids, our acid and base reactions and so forth, and also that we touched on in the Year 11 course. So this is a really good opportunity for you to review some of those concepts and develop some strength in that area. So the first outcome that we're going to look at today is investigating the correct IUPAC nomenclature and properties of some common inorganic acids and bases. So we look at this and we're going to investigate. So we're going to look into those. And inorganic meaning those not containing the element carbon, because that makes them our organic acids. So let's move into, first of all, our common inorganic acids. So we're looking at the nomenclature. That's the naming system that we use to name our compounds. Now, the system that we are using is the IUPAC system, which is the International Union of Pure and Applied Chemicals or Chemistry. And we use that to reduce any ambiguity between any international countries and so forth. So it's a naming system that everybody understands to reduce any confusion about what chemicals we are talking about. So our dot point, or our outcome, said that we need to be able to use the correct naming system for our acids and also the properties that they have. So if we look at the list down the left-hand side here, we have a whole host of formulas there, many of them that you would be familiar with already. So if we look, we go down that list. HCl, you're quite familiar with that one by now, where with our naming system of acids, if it comes in the form of HA, H being the hydrogen ion and A being the anion, our naming system, as you saw in the notes that you were asked to do over the holidays, is we are then naming by its anion. So in the first one, we've got our hydrochloric acid. In the second one, we've got our hydrofluoric acid. Going down, we've got there our sulfurous acid. So you can see there it's a sulfite compound, SO3. So that takes the form of the sulfurous acid. Next one down, sulfuric acid. Nitrous acid, again, looking at that, it's a nitrite compound, so it forms nitrous acid. Nitric acid. The next one you should be quite familiar with, that's your carbonic acid, present in most of your soft drinks, and then phosphoric acid. So with many of our acids that you would be familiar with, and if you think of lemon juice or vinegar, most of them have a sour taste. Some of those stronger acids and extremely concentrated acids can be corrosive to the skin. In solution, so if I put our hydrochloric acid into a solution, it will ionize and to form a donatable proton, so that +1 from the hydrogen that has the ability to lose 1 electron. It forms electrolytes in solution, and as you would have also found in your previous chemistry work, you would have noticed that acids will change the color of an indicator, and our acids are also then used to neutralize our bases. So if you think of that in a common everyday circumstance, there are some stings that, like a wasp sting, that we might add an acid to neutralize the sting of that wasp. And in the reverse we'll look at in a minute, you can think of bases. Bases do the opposite thing. Our common bases, they are then used to neutralize our acids. So let's look at bases. Again, we have got a number of different bases down here, and again, most of them you should be familiar with. The common one that you would have used a lot from Year 7 through to Year 12 is our sodium hydroxide, and it's given by that formula NaOH. So again, you can see that hydroxide formula there, indicating that it's basic. Another one that we have, which takes a bit of a different form, again you would have seen in your holiday homework, our ammonia is NH3. it is basic despite having a different form to the other bases that we have there. Some other ones, calcium hydroxide, magnesium hydroxide, and sodium carbonate, again in another form, Na2CO3. There's also another one that we do have, which is sodium hydrogen carbonate or sodium bicarb that you would see in your cooking, and it's NaHCO3. So while many of us don't have a tendency to taste our bases, they do have a bitter taste. So if ever you put some bicarb soda into your mouth, it does have that bitter taste. Again, like our acids, they can be corrosive to the skin, particularly in a concentrated form. They also form electrolytes in solution. Like acids, they do change the colour of our indicators, but to a different colour. Our soaps, they have a slippery feel. And unlike the acids that donate an acid, our bases accept the protons there and they neutralize our acids. So again, if ever you've had indigestion which is usually our stomach acid refluxing up, often you will take an antacid, which is usually something that is basic to neutralize that acid.